Welcome back, Chappelle. Welcome back, Honors. All right, yes, that's right. We have a joint flip right now, which is a little bit weird, I know, but it is what it is. So, and it's mainly just because this last little segment of this unit, y'all are both learning the same content, right? So y'all are talking about the scientific revolution. Thank you, Pierre. You're both talking about the scientific revolution. We talked a lot in our last classes, also in our last flips, about Nicholas Copernicus, Tycho Brahe, Galileo, Johannes Kepler, right? Talked about like the setup of the universe and like heliocentrism versus geocentrism and the church controversy. We went into a lot of depth as well with Galileo and his trials and tribulations with the church and how he ended up under house arrest and things like that. But a big thing to understand is that even though that this is a joint flip, you have to understand that we are in like slightly different places. So if you are a Western Civ like academic kid, if you are somebody who's in like my C, D, or G period class, you're going to fast forward this flip about like 10 minutes or so, right? But find where it left off on I Think Therefore I Am with Rene Descartes, and then that's where you're going to be picking up, right? But for our honors kids, let's go ahead and pick up right where we left off in that old janky flip that I had to reuse because I had a meeting the last time that I had to record a flip. So the big thing is, right, Pierre. Now, anyway, the big thing about it, though, that you need to understand is leaving off on Galileo, we now have proven and we now understand how the universe is set up, what it looks like, that the sun does actually, in fact, stay stationary, the earth goes around it, and we use the moons of Jupiter and our moon and all this other cool technology and all this other stuff. And also, Galileo, of course, is going to end up under house arrest. We talked about that. This, of course, is a great little political cartoon that may or may not pop up on your test. Is that, oh, thank you. On your test and stuff like that. But going forward, we're now going to even be branching out into other fields of science that were affected by this scientific revolution. One of the biggest ones happens to be kind of creating this new scientific idea, this new idea of like a scientific method, and the fact that a scientific method is meant to benefit the populace and benefit the people of Europe and benefit humankind in general. Thank you, Pierre. I know. So now look, but the big thing though is that we are basically in essence during the same time period, during when Galileo is having his struggles with the church and he's trying to actually advocate for heliocentrism, you're going to see the adoption of like a new scientific method. Now you know the scientific method, you've been learning it since middle school, right? That you have a question and a hypothesis and you set up an experiment, you gather your materials and then you do your experiment and then you record your observations and your experiment has a control in it and all that other stuff. And then you actually decide what if your hypothesis was correct, you analyze your data, and you come to a conclusion, right? So that entire model of scientific behavior, scientific research and study, that series of steps and analysis to solve a scientific question has existed since like the late 1500s going into the 1600s, right? And I know it seems like something very, very basic, but it actually is really, really important because science is now going to be being based off observation and experimentation, right? That's why we can look back at Galileo's stuff, not just his middle finger, but you can look back at his stuff and his ideas, his pamphlets, his book, A Dialogue on the Two Chief World Systems. You can look back on these items and you know that he was correct. We look back on his studies to find out that all objects fall to the earth at the exact same time. We, perform our own experiments and things like that. But the very first guy to kind of analyze that whole step process to try and understand where we got, how we got there, trying to understand the entire concept of having a hypothesis, creating an experiment, creating that series of steps, and actually using experimentation was a man by the name of Francis Bacon, right? So Sir Francis Bacon is what he was called. That's Rene Descartes, different guy. Sir Francis Bacon, who was a member of Parliament back in England, who worked underneath James I, the Stuart king, and then also later Elizabeth as well. Or not later, but before that, Elizabeth as well. Francis Bacon wrote a series of different books. One very famous one called New Atlantis, another one called On the New Sciences, and things like that. And in his books, he is going to advocate for using the scientific method, scientific research and study for solving human problems, right? He actually, in his book, New Atlantis, like designed this idea that there would be like a very like Hogwarts-like place, right? That there would be a place called the Solomon House, and people would bring their problems to the Solomon House, and a team of scientists would actually do research and experimentation to solve those problems for those people and the betterment of mankind, right? So in that book and in this idea of the Solomon House, he basically created, in essence, the scientific method, but not really. No one really invented the scientific method. He just kind of defined it, right? But a big thing about him is how he died as well, right? So what actually ended up happening to Sir Francis Bacon, he died from pneumonia because he wanted to perform an experiment to see if a chicken would survive longer if it was cold, a dead chicken anyway, would actually prevent it from going like bad or like spoiling, right? And so he actually like took this chicken and then went out into the snow and shoved it full of snow, but he forgot to put his jacket on and got pneumonia and died. So he even died performing his scientific method. But another very, very famous, very, very important guy is Rene Descartes, right? So Rene Descartes is going to take science in a whole new direction, though, okay? Rene Descartes believed that human reasoning can solve any problem, right? To try and diminish doubt. Because the big thing that Rene Descartes asked a lot of times is other than, why does my hair look this way? Not mine, his. Like, look at these bangs. It's rough. You know, like every person's gone through a bangs phase, right? Like, so I don't know if any of y'all are currently going through your bangs phase, but like his bangs phase was really, really rough. Now, Rene Descartes, though, he wanted to know, how do we know anything for sure? Do we truly know anything beyond a shadow of a doubt? Do we know something that is just like for sure, all the time, regardless of what we do or do not believe? And he came to this kind of conclusion that actually, one, that this idea of doubt is always going to exist, right? Because we are basing all of our intellect on human perception, right? And on the idea of if objects do or do not exist. Rene Descartes, though, is then going to actually cook his ideas down into a very, very, very existential problem, right? He then began to wonder, wait a minute, if I don't know if anything is certainly true, do I even know that I exist, right? So a big question that Descartes started asking himself is like, do I exist? Am I sure that I exist? Am I sure that I exist in this plane? Do I exist in this place? And he kind of freaked himself out a little bit. And then he started asking this question. And then eventually he came to the conclusion and he said, cogito ergo sum, which means I think, therefore I am. So he believes that if you have rational thought, that you must exist someplace. Maybe not here. Maybe I actually don't exist. Maybe you're watching this flip and you're making all this stuff up in your head. Maybe you're actually like sitting in a bed somewhere having a dream right now. Who knows, right? But we'll actually kind of scramble your brains with the existence model a little bit later on. And then also he just realizes, like, if I have rational thought, I can prove I exist. So you can prove that you exist personally, but you can't prove anybody else exists. But he also came up with a lot of different kind of like math pieces as well. Particularly, he came up with Descartes or Cartesian geometry. And another big thing that you use in geometry with Miss Bates all the time is a Cartesian plane. Literally, Descartes actually invented this thing, the Cartesian plane. So the Cartesian plane is the thing that you use in math all the time. It's literally the coordinate plane that you use with the y and the x-axis, right? He invented that as well because one night apparently he was staying up awake at night, lying awake, looking at his roof, and he saw a fly just buzzing around, landing on different parts of his roof. And he was like, if I made a grid system, I could figure out where that fly landed on my roof and chart where it went that entire time. And so he invented basically the Cartesian plane. And now, really quick, welcome back to the Chappelle academic kids, right? The academic kids are now paying attention because we are now learning this part together, right? So we are also during the scientific revolution going to see breakthroughs in medicine, okay? So medicine is going to take dramatic leaps forward, mainly because scientists and doctors are finally going to start doing something called performing autopsies, right? So you have to understand, before the scientific revolution, medicine was the most lackluster, dumb science out of all of them, right? Medicine moved along much slower than any of the other sciences. We knew that the sun was stationary and that the earth moved around it with telescopes, and we knew more about space than we did the human body up until this point, right? Honors kids, write this down really quick because you do need to know this. All medical knowledge that was around before this time period was based on an ancient Greek philosopher named Galen, spelled Galen. And Galen believed that there were 4 fluids in the body: blood, phlegm, yellow bile, and black bile, right? So honors kids, write that guy's name down. And every medical scientist based their ideas off that. And they also, this is going to lead to a very common cure for a lot of things. Most people during the Middle Ages, leading up to the scientific revolution, genuinely believed that you were sick because you had too much phlegm or too much bile or too much imbalance of one of these fluids. And so it led to the common practice of what was known as bloodletting. So bloodletting was the main way of actually performing anything medical on people during the Middle Ages. And what they would literally do is they would actually open up your vein and bleed you out into a dish, right? And they would literally look something like this. They would actually prick your veins and actually bleed you out into a cup, and they literally believed that bloodletting, or getting rid of your excess blood, was the best way to treat your medical conditions. We now know, because of the next guy we're about to talk about, that none of that is actually true, right? Also, there's this as well. If you've ever seen the barbershop pole, if you've ever actually gone with your dad or with a friend or something like that to go see a barber or go to a barbershop before, this right here is literally based on the fact that medieval barbershops were actually responsible for bloodletting, because they literally, the red, it symbolizes the blood, and the blue symbolizes the clean water, and this dish is where you held leeches, and that's where you caught the blood, right? So that is what medical science was based off of for a really long time. During the Middle Ages, they thought that you had fluids that were out of balance and out of whack, until this guy came along, Andreas Vesalius, right? Andreas Vesalius shows up, and he's going to be one of the most preeminent people that puts that entire idea to rest. It's Galen's ideas are wrong, bloodletting is dumb, and he does this because he starts performing autopsies. Now, why hadn't people been performing autopsies before this? Mainly because it was considered illegal to desecrate a Christian body. You couldn't cut them open and squiggle them around and see their heart and stuff like that. You weren't allowed to actually cut open a dead body after it had died, because it violated Christian law, okay? Again, the church being involved in this entire progression and story. Andreas Vesalius, though, starts doing it anyway, right? And he creates one of the very first medical textbooks, right? And he creates this by literally peeling human skin back and analyzing the muscle connections, tissues, organs, and everything else inside of the human body. And his book was called De Humani Corporis Fabrica. And literally this entire book is very, very important, because it became the very first medical textbook. And inside of it were all of these diagrams and pictures and different engravings of different human bodies that had the skin peeled off it and stuff like that. And even how the skeleton was assembled, because this is one of the most famous ones, and I absolutely love this engraving. I could never get a tattoo, but if I would, I'd consider getting this one, because he actually showed how the human skeleton was completely assembled while it was inside the body, right? And so De Humani Corporis Fabrica, written by Andreas Vesalius, becomes a very, very important textbook going forward, because it analyzed muscle structure, internal organs, skeletal structure, circulatory system, nervous system, and even the heart and how it works, coming off of actually William Harvey's work a little bit later. But he actually saw the heart. He didn't know it was a pump at the time, but he knew where it was located and things like that. And that book that he wrote, write this down, it's a great little piece of information. I might put it as extra credit on both of y'all's tests. The very first version of the book that he wrote, De Humani Corporis Fabrica, was bound in human skin, right? Because he had a lot of skin laying around. So he could actually make his book, and he had it wrapped in human skin, and that's what the outside of the book was made out of. So now that's kind of gross, but really, really cool. But Andreas Vesalius is wildly important, okay? Now, if you don't know what an autopsy is, go look it up, because it's just examining a deceased human body. Now, this is a very, very important piece of technology as well. And some of you are is that a ping pong paddle? No, it is not. That right there is the very first microscope, right? So even when we're talking about the breakthroughs in the medicines and sciences and stuff, a big thing is going to happen with the invention of the very first microscopes. Now, the microscope that I just showed you was invented by this Dutch man named Anton van Leeuwenhoek, right? Now, Leeuwenhoek is the guy that we credit with creating the very first microscope. And his microscope was really, really simple. If you're looking at right here, you're going to put your specimen right there, and you're going to look through that little pinhole, and it was very tiny, and you just held it up to your eye, right? And Leeuwenhoek actually used this microscope, and he designed the very first one to actually view cells and certain microorganisms, right? He actually is mind blown for the first time that he puts pond water underneath this thing. He put pond water under it, and he could see little critters and things like that running around. And so Anton van Leeuwenhoek leads to this entire new style of science of analyzing things that we can't see with the naked eye, right? And he actually saw in this pond scum all these moving organisms. And then later on, another guy shows up named Robert Hooke, who designs this microscope, right? And Robert Hooke designed a later one that was even better than Leeuwenhoek's. And Robert Hooke was very, very talented, and he actually is the very first one to discover cells. And I know y'all talked about this in biology, right? When you talked about this in biology, it was cork cells is what Robert Hooke saw. Because I talked to Miss Merrill and I talked to Miss Sharon, and both of y'all actually, like both classes, had discussed this. So Robert Hooke saw cork cells in an old wine cork, and he actually is the very first one to use this perfected microscope to start looking at other items. And another big thing about Robert Hooke is using his perfected microscope, he started drawing everything he saw. And this right here is one of the most famous things he ever witnessed. That right there is the drawing of a flea. Thank you, Pierre, for just gnawing on me. So he actually took a flea and put it underneath the microscope and looked at it, and he would draw and record a lot of his observations, okay? Now, then there's this guy who's wildly important, and I really hope that my battery hangs on. He is going to be the one that comes along and basically links all the sciences together using mathematics, right? And this dude is very, very famous, and Brooke Chatelain already knows him. He's very famous for apparently sitting below an apple tree and getting hit in the head with an apple, right? This guy's name is Sir Isaac Newton, right? So Sir Isaac Newton is then going to come along, and he's going to study a lot of different things, right? He's going to use science to explain the biggest and most important one, the law of universal gravitation, right? He is going to figure out that if I pick up this pup, right, if I pick up this dog, and if I were to drop him, that he's going to come back to the earth, right? And he explains that force, and he called it gravity, right? So Isaac Newton apparently was inspired by seeing an apple fall off a tree. He didn't actually get hit in the head with it. He used that story to explain the law of gravity to people who couldn't quite understand it, right? And he did a lot of work before this. He did tons and tons of work before he ever even came up with his laws on gravity, right? One of his biggest developments he came up with is he's the very first one to separate the light spectrum, right? So he actually is the very first person to come along with a prism, and he actually realized that white light is made up of every other color of light, right? That you can actually, that white light is the combination of all colors of light. This right here is Isaac Newton casting light through a prism and then seeing the light spectrum being cast onto that white wall. Now, funny little thing about Isaac Newton, though, as well, he wrote this in a book called On Optics, right? And he realizes that white light is made of red, orange, yellow, green, blue, violet light. Interesting little thing. I skipped one. Some of you are like, what about indigo? Funny little thing about Isaac Newton is he was super religious, right? Crazy intense Christian. Very, very Catholic. Or, not Catholic, he was Anglican, actually. But, very, very intense Christian. And he thought that having 6 colors was a mark of the devil. So he added in indigo so he wouldn't, be, upsetting, Christ and the church and stuff like that. So, actually, the indigo color that's in the Roy G. Biv doesn't need to be there. He added it just because he was, afraid of the devil, right? So, now, an interesting little thing about it, though, as well, is on top of all of that stuff, on top of realizing the light spectrum, explaining gravitational force, he also even came up with laws on energy and the conservation of energy, right? For example, one of the Newtonian laws is every action has an equal but opposite reaction, that energy and matter cannot be created nor destroyed. So Isaac Newton is a phenomenal intellect, right? Crazy intense guy. He gets knighted by Queen Anne. He's one of the most famous figures in all of English scientific history, and he even went on to create calculus to use that new mathematics to explain his law of universal gravitation. Because for a long time, people were like, okay, Galileo is probably right, and the sun might be there in the middle, and the earth probably goes around it, but what is keeping the earth from spinning off out into outer space? Isaac Newton comes along, he says, it's gravity. And he does that in his book called the Principia, right? So that is it. That is the flip that we are both sharing. Everybody is going to be taking their tests when they come back. I will see y'all then. Y'all have a good one.